Bismillahirrahmanirrahim. Hi everyone, welcome to the chemistry class. As you know, we are studying about the colligative properties. The fourth part of the colligative property we are studying is about the osmotic pressure. As you know, we have studied about the freezing point depression, boiling point elevation. Also, the last session was about the vapor pressure depression. Now, before starting the osmotic pressure, I'm going to say something about the osmosis. Osmosis is the passage. We have a tube in here. In the left side, we have solvent. In the right side, we have a solution. Also, this red part is what semi-permeable membrane. Semi-permeable membrane just allows only the solvent to pass. It means the passage of a solvent through a semi-permeable membrane is called osmosis. Also, it is remarkable that you should understand the movement of the solvent from the high concentration to the low concentration of water. For example, in here in the left side we have, because these are all solvent, pure solvent, we have a high concentration of water. In the left side, because it's solution, we have a low water concentration. The passage of the water from the higher concentration to the lower concentration is called osmosis. Okay, in this picture, as you see in here, we have three shapes. In the left side, we have pure solvent. In the right side, we have solution. Also, this yellow color shows the semi-permeable membrane. Okay, as you see in here, in the left side, we have a high water concentration. Also, we have in here what? Low water concentration. The water flows from the high concentration to the low concentration. Also, the right side will increase the volume. Also, we need an osmotic pressure. Osmotic pressure. The minimum pressure that stops the osmosis is equal to the osmotic pressure. When we have more number of moles of solute increase in a solution, the osmotic pressure of solution increases. It means when we have more solute, the osmotic pressure will increase. According to the definition, we have in here osmotic pressure. The minimum pressure that stops the osmosis is equal to the osmotic pressure of the solution. According to the ideal gases, we have studied that P times V is equal to N times R times T. This formula belongs to the ideal gases. Also, we can write like this. We can cancel them volume by volume is equal to N over V times R times T. Also, as you remember, in first chapter we have studied about the concentration of molarity is equal to mole over volume, solution volume. Instead of N over V, we can write, and instead of P also, the osmotic pressure symbol represented by pi. And instead of P also we can write pi. And instead of N over V also we can write C times R times T. It means we have two formulas for finding the osmotic pressure. One of them belongs to the non-electrolyte. It belongs to what? A non-electrolyte solution. Also, this one is what belongs to the electrolyte solution, because in here when our formula has 1-2 factor, also it means this belongs to what? Electrolyte solution. According to this formula, we have pi. Pi shows the osmotic pressure. What is the capital M? Shows the concentration of molarity, not molality. Also, we have the gas constant R is equal to 0.082 atmosphere times liter hour Kelvin times, I think like this. Also, this is in here also these are the same. Pi is equal to I times M times R times T. According to the osmotic pressure, I'm gonna solve one question from the osmotic pressure. What is the osmotic pressure at 298 Kelvin of a liter of solution containing 37.3 of potassium chloride. Also, the question gives us the value of gas constant R is equal to 0.082 atmosphere times lit hour mole times Kelvin. At first, we should recognize this question. This solution is electrolyte or non-electrolyte because potassium chloride is ionic bond. It is split into the ions. That's why we can say this solution is electrolyte solution. From this formula, pi is equal to I times m times r times t. We can solve this question from this formula. Okay, I'm going to categorize my question. Okay, we need the question asks that what is the osmotic pressure? Also, we have the temperature. It gives us 298 Kelvin at 1 liter of solution. Also, volume is equal to what? 1 liter. It means 1000 milliliter we have in here, containing 37.3 gram. Also, mass of potassium chloride, it gives us what? Potassium chloride gives us 37.3 grams. Okay. As you see in here, we have the value of R, value of T, value of I. It is so simple to find the value of I. As you know, potassium chloride, it will split or dissociate into the two particles ion. One of them is what? Potassium ion, another one is chlorine ion. It will give us how many particles? 2 particles. It means 2 mole particles we have. The value of I is equal to what? 2. In here, just we don't have the concentration of molarity. According to this formula, we can find concentration of molarity is equal to mole hour volume of the solution. Concentration of molality, also we don't have the mole of the potassium chloride. In here we can find that N is equal to mass hour molar mass. The mass of potassium chloride is equal to 37.3 hour. What is the molar mass of the potassium chloride? We can find from here. It is 35.5. Also in here it will become 74.5. When we are going to simplify them into, it will be equal to 0.5 mole. Also, from this formula, from the concentration of molarity is equal to mole over volume of the solution, we can find the concentration of molarity. What is the value of mole? We have 0.5 mole. Also, we have in here. Also, volume of the solution, it gives us the 1 liter. As you remember that the volume should be according to the liter. We have 1 liter. 0.5 divided by 1 is equal to 0.5. Mole time divided by liter, it will give us what? Molar. Now we have all the values. Pi is equal to, what is the value of I? We have 2 times, what is the concentration of molarity? We have 0.5 molar we have in here. What is the value of R? We have 0.082. Also, what is the value of temperature? In here we have 2098 Kelvin we have in here. We can cancel them to the molar to molar, mole and liter. Also, we have in here Kelvin by Kelvin. Also, we can cancel them to each other. It will remain what? Atmosphere, the unit of osmotic pressure. In this question, it will give us according to the atmosphere. 2 times 0.5 will be is equal to 1 times 0.082 times 298. Okay, when you are multiplying them together, it will give us 24.43 atmosphere. Okay, now we are going to study the solutions according to the electric conductivity. As you know, some substances conduct electricity and some cannot conduct electricity. According to the electric conductivity, solutions can be electrolyte and non-electrolyte. As you know, ionic compounds split or dissociate into ions when they dissolve, forming more particles. Those compounds, when they dissociate into the ions, is called electrolyte, and those compounds, like covalent compound, stay and as complete molecule is called non-electrolyte. Electrolyte can be weak or strong. We will study each one by one. What is the electrolytes? Those substances whose aqueous solutions are conductors of electricity and provide free moving ions. It is so important, it should provide free moving ions. For example, we have solid sodium chloride, solid of sodium chloride, it contains ions, but they cannot move. So solid sodium chloride is a non-conductor by itself. When we are dissociating sodium chloride into the water, it will provide free moving ions. Like, for example, HCl plus water, hydrogen chloride, when dissociated into the water, it will give us the hydronium plus ion of chloride. It will ionize completely. It means electrolyte can be weak or strong. It means we have two types of electrolyte. What is the strong electrolytes? The electrolytes at which ionize almost completely. It means those substances which they ionize 100% are almost completely in their aqueous solutions and produce more ions. It's called strong electrolytes. Strong acids, for example, strong bases and soluble salts are strong electrolytes. For example, strong acid, we can say like these molecules or compounds. Hydrogen chloride, for example, hydrogen bromide, we have hydrogen iodide, we have in here. We have sulfuric acid, for example, we have nitric acid. These are what? Strong acid. Also the bases, the hydroxide of the first group and the second group, they are strong bases. For example, sodium hydroxide, like potassium hydroxide, we have strontium hydroxide. Okay, these are what? Strong bases, and those salts that they are soluble are strong electrolytes. Electrolyte can be weak electrolyte or strong, as I told you. Weak electrolytes cannot produce more ions. I will show one picture for understanding better the strong electrolyte and weak electrolyte. What is the non-electrolyte? Those substances whose aqueous solutions do not conduct electricity. It means they do not dissociate into the ions, they dissociate into the molecule, is called non-electrolyte. For example, when you're dissolving sucrose or glucose into the water, for example, glucose or sugar sucrose does not ionize at all in solution. That's why we can say that glucose or sugar, they are non-electrolyte and does not conduct electricity. Okay, it means it will not dissociate ions. Okay, it is one kind of what? Non-electrolyte. As I told you, we have one picture in here that you can recognize what is the strong acid and what is strong electrolyte and weak electrolyte. They are the same. As I told you that HCl was one of the strong acid. HCl also, it dissociates completely into the ions. As you see in here, we have hydrogen ion, chloride ion, all the particles dissociated into the water. But as you see in here, we have carbonic acid. Carbonic acid does not dissociate it completely. As you see in here, we have a small amount of this particle that dissociated into the ion, and some particles remains also the carbonic acid. Also another picture we have in here, like ethanol, it is a non-conductivity because it does not conduct electricity. Also it does not have free ions, it does not have ion. The second one is one of the strong soluble salt, potassium chloride. It has a high conductivity. Also it has more free electrons. ions as well. Also, the last one is acetic acid solution. It is a low conductivity. Acetic acid is a weak electrolyte in water. Only 1% of, I think 1% of acetic acid molecule ionize. Also, that's all for today. Thanks for watching me.